Okay, so an angle measure 75. What is this? Complement. Hopefully you guys said 15. Complement always adds up to 90. Supplement is 105. If it's y, you would just say 90 minus y, 90 degrees minus y, or 180 degrees minus y. So those make sense? We're good? Okay. For number 3, name two right angles. Definitely you can say angle P. And you can say IPS or SPI, but angle P is good enough because it's not ambiguous. Then you can say angle NIP. Or you can say, yeah, you have to say angle NIP because say angle I is kind of confusing. Angle NIP, because that's total 90. Two adjacent complementary angles, so add to 90. Definitely say angle NIS and angle SIP. Those add to 90, right? And they're right next to each other. Two adjacent non-adjacent complementary. So they're not next to it, but they add up to 90. You could say angle ISP, which is 40, and then angle SIP. Name a supplement PSN. So it has to add up to 180. At PSN is well, it's 100. Oh, 80 degrees. So angle SNI. Yeah, that's a little confusing. I was confused. What does angle PSN add up to, guys? PSN. What's that up to? And what's when you take away when you do 180 minus 100, you get there you go. So that's the supplement. Angle SNI. Um, Name another pair of supplementary angles. You could say um let's see, you can say angle NIP and angle IPS because those add up to 180. 90 plus 90. So you have to think a little hard about those problems. I will say these questions are probably the more challenging questions on a geometry test. These are where people tend to lose points. So I would advise that when we do have this later in the year, that you kind of spend extra time at office hours or working with the teacher or tutor or class, whoever you work with, to really get a lot of practice on this, because this is where people can get a little confused. Question on 3? All right. For 4. What's up for 4? Two congruent supplementary angles. So they have to be the same and add up to 180, so it'll be 90, 90. So I'd say angle CHK and angle AHK. Because those are right next to add up to 90. Two supplementary angles are not congruent. You could say angle AHL and angle CHL. They obviously form 180 degrees, but they're not congruent. Complementary, because that's 90, that's 90. So you can say angle AHL and angle LHK. Because that and that add up to 90. Straight angle will be angle CHA. Yeah, I don't think there are multiple responses. I think those are only responses you could say for that one. Question on 4. Okay. Next up, if angle 4 is 40 degrees, usually what I like to do before I answer the questions, well, actually, the question is to answer all the angles. So anyhow, that's fine. But we'll just kind of just start labeling and just start getting everything else while we're at it. Okay, let's start with angle 6. What do you think angle 6 is going to be? Yep, because you had 44, it's 80, so you have to make a straight line. Well, straight angle, sorry. All lines are straight. Is 7 opposite of 4? Yeah, when they're opposite each other with vertical angles, that's also going to be 40. 8's opposite of 5, that's also 40. 9's opposite of 6, that's 100. Plus, you have to add to 180 for the straight angle. Okay, all's good. All right, so that's that page. For number 6, ooh, good one. Told you I love these problems. Angle 1 is x squared minus 2x. Angle 3 is 35. What's the relationship between those two angles? Are they the same? Yep. Either they're gonna be the same or apt to 180. That's usually what's gonna happen. Sometimes get up to 90 depending on the diagram, but usually they're gonna add up to something or they're gonna equal each other, right? So that's what you do. You set them equal to each other and you go about solving. Remember, solving, we got to factor. But how do we factor? This is why we have this class, right? That's why we spend all this time talking about solving quadratic equations by factoring. You got to move everything to one side first, right? Move everything to one side first. And then you could actually get your answers for x, right? X minus 7, x plus 5. So x equals 7 or negative 5. Is negative 5 gonna be okay? Yeah, it'll be. So it'll be okay. Yeah, it will be. So both are fine, actually. Both, just because the answer is negative, don't automatically discard it. Check to see if it's valid when you put it back into the expression. Remember, what makes it valid? As long as a geometric, thing, whether it's an angle, line segment, whatever, is positive, right? We can't have negative angles, can't have negative sides, right? So just always throw it back in to the expression to make sure it's positive. That's valid. Okay. Yeah, 9 through 13 is kind of like number 3. Students going to struggle with these problems. But what do we do? Let's take a step back, right? Let's take a step back. Now, QRS, it's kind of confusing. You only need 3 letters. You only need 3 letters to define the plane. Yes, there's of course 4 points on that rectangle or square on the bottom, of course. But you only need 3 points to define the plane. But T is part of QRS, just so you know. T is not excluded, it's part of it. And then RSW, fine, but V is part of RSW, right? So if you think about it, it's gonna be a little hard to work through on this one. I'm going to shade this, and I'm going to shade this. What do they have in common? What line? Yep, RS. You know, another way you could tell too, R and S are in both planes, the labels. That's how you can tell. And it's a line, by the way. Sorry, it's not a segment. It's a line. Because planes go on forever, as we talked about, lines go on forever too. So this is something that just extends forever, in all those directions. For TXW, TXW, which is right here, and UQX BXT. And 2 planes intersect at QU. So you could say plane, I'll do down here because I'm out of space. So UQ is right here. So I want that one and the front one. So I want the left. So if you look at this way, right? I want the left face and the front face. Now the left face, you can say XUQ if you want, XUQ or UQ. I don't know. I just mix these letters up like crazy. But XUQ. And the front face, I can say QUV. I can say that. So front and left. For 12, and 2 planes intersect at VW, I can say plane, the top, right? So I can say XWV. And the right, I can say RVW. Sorry that my and symbol looks terrible. In plane, RVW. Fine for 13. Draw an arrow to the plane that contains RVW. So RVW is the right face. If I draw a line, draw an arrow to the plane that contains, draw an arrow to the plane. Oh, yeah, then you do this. It's kind of like if I took that box of chips or box of Oreos and took like maybe a sharp pencil or pen, I don't know, or this, or just anything sharp out of the kitchen, right? That knife, just jab it, right? So, for example, it would look like this. Like a jabber. But yeah, so we have the box of Oreos here. So the left base where we have all the nutritional information, this is not nutritious at all. If I took this line and just jabbed it like this, that's what's happening. You know, come out the other way, right? So that's what's happening. This is with an arrow through. So think like that. Questions on 9 to 13? All right, then lastly, the matching. I think all these letters will be used. Yes. Okay. Let's do a round robin. And it's okay if you got it wrong. It's okay. But this will help us be efficient. So Jake, what do you get for one?
D.
I would agree. Yep. You guys agree with D? Okay. 2, Adam, what do you say about 2? Let's see. Okay, align. Set up points in a straight path. Yeah. Yeah, good. Excellent. Nice. Okay. And give me a sec, guys. I need to process this. 2 lines that form a right angle at the point. I'm gonna say I. Yeah. I like I better, guys. Yeah. Because you're totally forming 2 lines. Okay. Peter, yeah. Position of space often. Yeah, dot. Yeah, that's pretty straightforward. Okay, Evan, what do you think? Huh? Let's see. A fine portion of a line that has two endpoints. It's going to be a segment, actually, because it doesn't go. Because remember, ray goes forever, right? Like a light ray, right? But it doesn't go on forever. It has 2 endpoints, and it is a portion of a line. So that should be J. Right now, we think about 6. Okay, 3 or more points that lie in the same line. So they're all in the same line. Remember we talked about like a co-pi that got 2 pilots, co-captains. So wherever we see collinear, do you see collinear? Where do you see collinear among the choices?
Yes.
Yeah, what choice would that be? Correct, that'd be H, right? Because they're the same line,
Uh-oh.
right? Okay. At the end, what do you say for 7? The point that bisects. Yeah, it cuts it in half. Yeah, that's exactly it. It's the midpoint. Okay, Kels, what do you think about 8? Yeah, the parallel. Yep. All right, Bella, what do you think about 9? So it has an endpoint and goes forever one direction. What do we call that? Array. Good. Yeah, good. Yes. So let's see. Yep. Okay, Allie, what do you think about 10? So it's a flat surface and goes forever. It's 2-dimensional. Plane. Yes. Good. Good. All right. Okay, I'll do the next 4. But I appreciate you guys sharing. That's good. Even if you're wrong, it's okay. You know, it's okay. You know, it's all a safe place. We're all here to learn. Now, 11. 2 rays that share an endpoint and extend. That's an angle. So that should be wait, where the heck is it? Am I wrong about 2 rays that share an endpoint? Oh, wait, and extend. Oh yeah, duh. Of course. Yeah, sorry. They're opposite direction. I see. Yeah. Something that relates to or resembles a line. Yeah, linear. Yeah. Okay. All right. 3 or more points that lie in the same plane. I think that's N. Yeah, because we have to use N. I'm pretty sure that's N. That's a weird one. I never heard that rule. If 3 points are coplanar, then the line contained 2 is in the same plane. That's coplanar points. Wait, crap. It's M then N. Yeah, my apologies. Yeah. Yeah. I didn't see M. Those are coplanar points. And an N, if 3 points are coplanar, then the line containing it, yeah. Because that line has to be on that plane. Right. Okay, that makes sense. Okay. So those are those answers. I'm actually going to take a picture of that so I don't have to do this over again. because I want to give you guys the answer keys. Let's see here. Cool. Then these guys here, more of the same stuff. Which one's a line? Which number? Yep, so B. Which one's intersecting, guys? Yep. Which is a segment?
16.
Which one has a bunch of points on the same line? It's collinear points. And then coplanar points? 20. Parallel? B. Yep, got it. Good. Yep. Good. Okay. Awesome. Okay, so let's do notes for today. So we're talking about lines today. Also some lines. This will be pretty manageable. I didn't get stuff for break. I didn't do that yet. And then after the break, we could do lots of delta math.
Yay.
Yeah. Try to get that. Like try put a big dent in it today. Be huge. If you're already finished, I have an extra delta math you could do. Also we'll do a homework quiz as well. The homework is very short today. And also, hopefully, because it's the weekend, maybe we could try to get head start on homework and get that done so you have nothing to do over the weekend. Homework's pretty short also. So we're gonna try to, so after the break, delta math, homework quiz, and work on homework. So.
Oh, wow. There.
What kind of spider is it?
Disgusting.
What kind is it? Let's see.
I think it's spider. Oh,
Stop.
you know, here.
I'll give you the spider for his house.
You don't have. No, Jake, stop it.
My step up? Oh. Well, we
Hey.
What do you want to do?
there's some tissues. Some tissues left. All right. Yeah, my wife is one of you freaks out, so I have to take care of the spiders in my house. So we sometimes get black widows. Yeah, I kill them. I guess we actually have one of those zappers too. Those fly, and that works for spiders too. Just put it next to it, it kills it. So it's actually pretty fun. Okay, that's scary. But I know they're harmless, but that freaks me out. Not too often, but so.
So like, think somebody. Or I might be making that.
All right, guys, enough excitement. Let's get back to the notes here. All right. Lots of ants are terrible. If you don't take good care of your house or have food. Cockroaches. Yeah. 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 It's tropical. Okay, guys, we got stuff to do. Guys, let's get back. Okay, good. Now you're getting social. It's good, but we got to get work done. All right. So slope. Slope's a big deal. It's covered in Algebra 1. It's reinforced in geometry. It's reinforced in Algebra 2. We talked about pre-calculus. In fact, actually, it's the foundation of calculus. The first semester of calculus is all about slope. So slope is definitely one of the biggest things you do in high school math. Very simple. It's just going to be the rise over run, the change in y over change in x. That's all you ever do. So if I were to sketch each of these scenarios, I'll draw 4 different coordinate planes. And I'll do a different color for contrast. So positive slope could look like this. Negative slope looks like this, like going downhill. So think about if you're going from left to right, we're going uphill, downhill. Zero slope is flat. Undefined slope is vertical. And undefined because you can't divide by 0. That's why we say undefined. Examples. I'll just do one and have you guys try the next two. That's pretty straightforward. Just 2 minus 1 over 3 minus -2. So 1/5. All I did was subtract the x's and y's. Like that. Right. So the 2 minus 1, 3 minus -2. Now, could I have reversed the order? Could I have done 1 minus 2 first and -2 minus 3? Yeah, it won't matter as long as you're consistent. If you want to go first point minus second point, I don't care. But you gotta be consistent. And of course, don't mix up, don't put x in the numerator one and denominator, because it has to be rise over run. So what you're doing is you're looking at how y changes with x. It's a ratio. So what we expect, the 1/5, by the way, what it means is that every time x goes up by 5, what does y go up by? 1, exactly, correct. So if I were to plot this, it would go, up 1, right 5, up 1, right 5, up, or right 5, up 1, right 5, up, whatever it is, right? But that's a ratio. It's consistent per line. That's why it forms a line. Okay, go and try 2 and 3 really quick. And then we'll move on to 4.
It doesn't, I can't believe it's not sad. It feels like a Wednesday or like a Thursday. We're like halfway done with,
Yeah, we're halfway here. Yeah.
But you're right in this ball. It's 3 months.
All right, here we go, guys. Undefined and 0. We're good. Let's keep going. You can't divide by 0, right? Undefined and 0. And the reason why I say undefined, by the way, I don't know what -10 divided by 0. I have no clue. Like, because division, if you think about it, like what if I have 4 divided by, or what if 8 divided by 2, right? Why does that equal 4? As you guys learned many years ago, doesn't 8 equal 4 times 2, right? That's why we can say that. But if I have like 8 divided by 0, I'll put a little question mark here. What would I multiply to 0 to get to 8? Is that even possible? No. That's why I say it's undefined. There's no definition for it. Hence the name undefined. You can never ever divide by 0. But 0 divided by anything, that's fine. Because 0 would equal -5 times 0. Right? Because you have no groups of -5. Yeah, you go, yeah. You have no groups of -5. So yeah. Or you have -5 groups of nothing. So that's nothing. Okay, for 4, find another point on the line through that with a slope of 1/3. I would recommend using the point slope formula. I'm not sure if you guys remember that. It's actually the preferred technique in more advanced math classes. And we just prefer you leave things that way. In fact, actually in AP Calculus, they prefer you leave things that way. If that's a class to take much later down the line. Or causal calculus. So anyhow, that's just going to be, oh, wait. What am I doing? Why didn't I read the question? It didn't ask for the equation line. I'm sorry, guys. I'm glad I talked about it. It asked for another point. That's stupid. Okay. So what would you guys say? So you want to go up? Oh, you want to go up 1? Up 1, right 3. So if we go up 1, right 3, I'm going to do -2 plus 3 and 1 plus 1. What's -2 plus 3?
1.
So 1 comma 2. Plus, if you plot the points, that's probably the best thing to do, I think. Yeah, if I go up 1 and right 3, there you go, 1/3. Sure, yeah, look. So 1, 2 would be another point. You could say a bunch of other points. Now, are these collinear? So we have to have the same slope. So let's do this, guys. Let's call this ABC. What I want you to do is find the slope of AB. And find the slope of BC. If they're the same, then they're collinear. That's the only way to do it. You have to find individual slopes for two different pairs of points, or pick the first two and last two, whatever, right? So if I do 7 minus 3 over 2 minus -1, we should get 4/3, I think. Okay, if we get 4/3 for that one, the answer is yes. If not, it's no. 15 minus 7, okay, well, that's 8. But hold on, could reduce. 8 minus 2, that's 6. What does 8 over 6 reduce to?
4/3.
So the answer is yes. Let me erase this other junk because it's from the previous problem. Okay. Parallel lines have slopes that are equal. We talked about this already. I mentioned this early in the week. Perpendicular lines have negative reciprocal slopes. They're negative reciprocals of each other, meaning you flip and change the sign. Given a slope, given a line has a slope of -2, what's up with parallel line? -2. That's obvious. Perpendicular. You can write that as a fraction. Any number can be a fraction. Just put over 1. So think of that as -2 over 1. Flip and change the sign. What happens when you flip and change the sign? If I flip it and go from negative to positive, what do I get? What fraction? You can say it. 1/2? Yeah, you get 1/2, right. Another thing too for perpendicular lines is you can multiply both the slopes. It should always come out as -1, which it does. Totally does. So all right, let's keep moving. Graphing. Did you guys do this in Algebra 1 last year? Okay, so should we review? 3 forms. Okay, I got a little ahead of myself. Point slope form, that's very popular. It's right there. Slope intercept, y equals mx plus b. That's easy for graphing. Standard form is probably easy for solving systems of equations if it's written that way. So we have all 3 ways written. So I'm gonna kind of do some labeling here before we do the graphs. Okay, before I do 3. So what I'm teaching you guys right now is efficiency. Okay. The one thing about math, I'll just kind of, I'll get on my soapbox here, is you gotta be incredibly efficient. So math, sometimes we get stuck, we go to stare at the too long, we run out of time, sucks, we don't like that happening. Personally, gets some accommodations, even though you still run out of time. That's because sometimes you guys resort to techniques that are totally inefficient. And I look down like, oh geez, this is not efficient at all. To get the slope here, you want to recognize what form this is. What form is this in? So boom, x side, there's a slope. What does -2 represent? B. What is B going to be? The y-intercept, right? So I have information right away to do the graph. Here, this is point slope form. What's x1, y1? x1 is -3, y1 is +1. What's the slope here? 2. I got a point, I got a slope. I can do this. Now for 3, I've seen some students try getting y by itself. You could.
Again, slope intercept one to do that. But I would personally find my intercepts right away. For example, what if y was 0 here? What would x equal? If this went away, what does x equal now? 6. What if x went away? Was y equal? -4. Good. So you have
6 comma 0 and 0 comma -4. So 6 comma 0. Oh gosh, it's hard to read. 3, 4, 5, 6. So yeah, there you go. Just connect those two dots. Here, -3 comma 1. Up 2/1. Sweet. There you go. Y-intercept's -2. Down 4. Right 3. So is that -2. That's at -3 comma 1. And of course, -4 and 6. Okay, that's not the best color. That's a little hard to like. But notice they even say right there, x, y-intercepts, right? The point at which a graph crosses the x-axis. So any number comma 0. Y-intercept, the point at which a graph crosses the y-axis. 0 comma any number, or 0 comma b. But that's the efficient way for doing that. You don't need to make a table. You can. That's why it's taught. But at this point, no pun intended. Guys get it? Right. Okay. No, keep coming. These jokes keep coming. We don't know. To keep doing tables, it just doesn't make sense. So it's better to be efficient, right? We don't want to keep doing tables over and over again because it just takes too long. Right. All right. Yeah. So let's find the intercepts here. And then we'll talk about graphing vertical and horizontal lines. I'm gonna make a little table here. Actually, we kind of already did this. Yeah, we already did for number 6. That's 6 comma 0. And 0 comma -4. We have it partially done for number 4. That's 0 comma -2. Kind of don't have it for 4 and 5. So that's a little harder to do. So you have to do a little bit of algebra. Not fun, but we'll do it. I'll just do it in my head and I'll give you guys the answer. But x-intercept, what I'm playing 0 for what? I want x-intercept 0 for x or 0 for y. I want the x-intercept 0 for y. But then I'm gonna add 2 and then multiply by the reciprocal of that, which is going to be -6 fourths, which should be -3 halves, I think. It looked like that was the case. Yeah. It'll be -3 halves comma 0. Do the math on paper. Don't do it in your head like I did, because I can make mistakes. But I think that's it. For 5, that's not a fun one. If I plug in 0 for y and solve for x, should get -7 halves, I think, comma 0. Yeah. And 0 for x and solve for y, that should be 7, I think. Yeah. When you graph a vertical line, it looks like this, like x equals 4. It will kind of look like this. If you graph a horizontal line, it'd be look like this, like y equals 2. These are just examples. Right? So pretty straightforward there. Okay, questions so far? Nope. All right. So let me give you a little push on the next page, just give my voice a little break. Let me just let's just read a little bit first. Then I'll give you a little guidance. 1 through 6 and walk around. Just give my voice a little break. Jake, can you read the opening paragraph?
You should be able to write the equation of a line given the following information. A point on a line and its slope, 2 points in the line, a point in the slope of the parallel line. We call parallel lines have the same slope. A point in the slope of the perpendicular line, we call perpendicular line slopes are opposite reciprocals.
Okay, thank you. I appreciate it, Jake. So number 2 is like that first scenario, right? Do you see a point and a slope? You're given that. 2 points in a line, that's like number 3. If you're perpendicular to a line, that's like number 5. So anyhow, those are just some examples. And standard form, we have that. Slope intercept form, we have that. Point slope form, we have that. How you write the line, I don't care, but I think just to make you guys feel comfortable, let's do for slope intercept form, let's do that for number 1. And for point slope form, let's do that for most of these. Point slope form, we'll do it for number 2, number 3. Number 4 is gonna be kind of weird. Number 5 and number 6. We actually can go through the first couple pretty together. That should be easy. So for number 1, we can write in slope intercept form. Do you have the slope and y-intercept for number 1? You do. So we're gonna say y equals what? Done. Easy peasy. Done, right? So check that off. Okay, 2. Let's do in point slope form. Are you given a point and a slope? Yep. So y minus y1. What's your y1 here? So it becomes positive 2. What's your slope? X minus what? Boom, done. That's why that's a popular form. And it looks kind of weird with the plus plus, so I'll just kind of get rid of one of those pluses. Make it y plus 2. Yep. Okay, cool. All right. For 3. Now 3 is going to require a little more work. You guys have any questions so far about 1 and 2? All right. Yeah, 3, 4, 5, 6 require a bit more work. What I want you to do is find the slope. If it's vertical line, it's going to be x equals something. For 5, you'll need to isolate y. And then find slope. And then do negative reciprocal. I'll abbreviate negative recip. For 6, what does it mean to bisect? To cut what? Cutting what if you're bisecting? So you need the midpoint. Then the perpendicular slope. Because it's perpendicular. So go and do this. I'll walk around, help you guys out. We'll work that out.
All right, we guys are saying the slope of number 3. Kind of weird. 7/8.
Yeah.
Yeah, kind of weird. 4x equals what? Oh, just take the x coordinate, yes. What do you guys get for slope for number 5? Yeah, how can we get y by itself?
X equals 6 and y equals -4.
Right, but we want the equation aligned though. So we definitely want the slope. I mean, you can use that to get slope. If you have negative 0,4 and 6,0, you can, how far do you run in ruts? You can use it. Actually, that's a great observation that Jake made. If you for number 5, we already saw that line already. If you have the x and y intercept, you can actually totally figure out. Oh, it's perpendicular. Yeah, well, still, that's okay. The slope of that I think would be 2/3. Yeah, but then you have to flip it and change the sign, and then use 5,3. I'm gonna work this out in just a moment. What do you guys get for the midpoint for number 6? What was the midpoint for number 6? What's halfway between 7 and -1? Add and divide by 2. What's 7 plus -1 divided by 2? Close, 3.
Sorry,
3, right?
oh yeah.
What's 9? What's half of 9 and 4? Halfway between 9 and 4. Add them up. 9 plus 4. 13.
13.
Divide by 2. 6.5. Yep, good. Okay. And then you have to do negative circle. So let's work these out so we
can take a break at a proper time and just get this done. So the slope here, -4 -3 over -7 -1. Both negative. So that should be 7/8. So you're going to say y -3 equals 7/8. By the way, you could have used the other point for x1, y1. You didn't have to use the first one. It wouldn't have mattered. That's x equals 5. Because if you think about that one, 5 -3 is right here. Okay. If you get y by itself, let me close the door because I really want to get this done. -4, I think. So the slope here, let me close the door.
So yeah, remember you get y by itself. You have to do the 2x over divide by -3. After that's done. Yeah, once that is done. You can extract the slope,
Which is 2/3. However, it's got to be perpendicular. So I'll do this, the little symbol here for perpendicular. What's that flipped over and changes in sign? -3/2, right? So you're going to say y -3 equals -3/2. Okay, I can't do 3's for the life of me on this. Times x minus 5. And then for this one, 7,9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1,4. And halfway between that was 3, 6.5. 3. We'll say 13 halves. Leaves a fraction. And then you have to go perpendicular to it. So the brown line is what I want. The slope here is going to be 5/8, I think. Yeah. 5/8. So your perpendicular slope is going to be -8/5. So you're going to say y minus the midpoint. So we're definitely using point slope form. -8/5 x minus 3. That's a definitely more challenging one. I think we need to review this next week for sure. But let me backtrack, and then I think we should take a break after this. We'll do the last page when we get back from the break. Gotta find a midpoint. There you go. Plot it and you find it. Average x, y coordinates. You gotta find that slope, and you need the perpendicular slope afterwards. That slope is 5/8, so you flip it. Once you have the midpoint and the slope, go to point slope form. Got it. All right, take a break. 9 to 5, come back to 10 to 5.
I don't know where you.
All right, so let's talk about the last page of the notes, and then we're gonna do a bunch of delta math for a while. I'm gonna come around and see how you guys are doing with delta math too, so I can kind of help you move forward. All right, so these are new things, and you'll definitely see this often in geometry. I don't expect you guys to fully embrace this today or even next week, but we'll talk about it, introduce it, and it's gonna get reinforced like crazy throughout the year. These are pretty important topics, and something that kind of just reappears in later math classes. So, corresponding angles. So, corresponding angles are angles in the same or corresponding position on the lines. Let me give you an example of corresponding angles. I'll get a highlighter out. That's going to be, I think, good for us. 2 and 6. You see how those are in the same position? See how 2 is above line L, 6 is above line M, and 2 and 6 are both to the right of line T. So those are called corresponding positions. When those are equivalent, or when the lines are parallel, sorry, when the lines are parallel, angle 2 is going to equal angle 6. So angle 2 will be congruent. Remember, the congruent symbol is an equal sign with a squiggly line up top. So when the lines are parallel, 2 and 6 would be the same. By the way, 1 and 5 would be the same, 3 and 7 would be the same, and 4 and 8 would be the same. Those are also corresponding angles. So angles are in the corresponding positions. Okay, alternate interior. Think about the words. It's a play on words. That's all it ever is. Alternates. You alternate. You rotate. Switch. Right. Interior. Inside. Right. So look at 3 and 6. 3 and 6. Are they inside lines L and M? Yeah. Do they alternate on opposite sides of line T? Yeah. So those are also. That's another thing we have to look at. So let's get a highlighter out again. So 3 and 6 are called alternate interior angles. Now, when the lines are parallel, those are going to be the same. Again, angle 3 is congruent to angle 6. So when the alternate interior angles are the same, we can say the lines are parallel and vice versa. When lines are parallel, angles 3 and 6 will be the same. Likewise, of 4 and 5. Okay, same side interior. We're on the inside, but now we're on the same side of line T. We're on the same side of line T. Now, when that happens, then a 4 and 6 are not the same, by the way. Just look at it. They don't even look the same. How do you think 4 and 6 are related, though? So what would they add up to? What do you guys think? Well, think straight lines. No. Angles 4 and 6. The measures. Sorry.
Oh.
No, of course 4 + 6, yeah, we know that, but what I meant was. Okay, for example, what if this is like 50 and 50, right? If that was 50, this you misunderstood the question. That's right, if that's 50, what would angle 4 equal? No, what's 180 minus 50? 130. And 3 and 6 are the same. If that's 50 and 130, what are those adding up to now? Yes, 180. That's right. 180.
So they add up to 180. So that's what we're going to say for that one. We're going to say add up to 180. So angle 4 plus angle 6. Actually, the measure of angle 4 plus the measure of angle 6. That's kind of the proper way to write it. I am teaching geometry after all. I gotta be proper. Equals 180 degrees. Because if you think about it, what if this were 50 degrees and that were 50 degrees, right? And that were 50 degrees and that were 50 degrees. And that were 130 and that were 50. So what's 130 plus 150? That'd be 180. Okay. Alternate exterior. So you're on the outside now. And exterior is outside. I don't want to move the screen. So let's look at like say 1 and 8. Okay, kind of hard to read.
1 and 8. So those alternate, but they're on outside of L and M, and the opposite sides of line T. Those are also going to be equivalent.
When those are equivalent, the lines are parallel still. So let me redraw that. 1 and 8. When the lines are parallel, those are going to be the same as well. Okay. Same side exterior. Those will have the 180. Just like the same side interior. The measure of angle 2 plus the measure of angle 8. And lastly, vertical angles, they're always congruent. For example, like angles 2 and 3. Those are clearly directly opposite of each other, so or across from each other. Now remember, complementary angles add up to 90 degrees. Supple's more, 180. Adjacent angles have a common side and vertex. And don't engulf each other. I think that's probably what we said earlier. You can't have like one angle be part of the other angle. Like what I mean by engulf, we saw this earlier. You can't have that and all that. That wouldn't make sense. Okay, so that's good. So we definitely can now pump the brakes a little bit. Let's do some delta math. Probably for about 15-ish minutes. Then we'll do the homework quiz brief. You can go back to delta math, or you can start the homework. So I'm going to come around to kind of just to record where you are right now, and see what I can do to help you guys move forward. Because we definitely want this done by this time the class is over next week. You do not want by a week from today, August 8th. Okay, well, I haven't done this yet, and I now got like all the summer reading. I got like sports and other stuff. Let's just get this done. So, and if you're still in the beginning, it's totally fine. But by next week, we should have it done. And if you're already finished delta math, you can do the next one. I think I emailed you guys. Let me email it again.